right, guys. Hi, we're getting started on the new lesson. We are in lesson 9.1. If you want to follow along with me, actually, you should follow along with me. We are on page 362 of your textbook. Whether you're using the online one or your hard textbook, that's where we are. So we're starting this new chapter on, excuse me, on circles. First thing I want to do before we get started on the new stuff, we're going to do a little bit of review. So let's say I have a square, right? So I have a square. That's a circle. Let's say I have a square. There we go. So, and let's say that that square had sides, and we know that since it's a square, all the sides are the same, that the square had a side of 4 inches. And I asked you to tell me what is the perimeter of that square. I'm just going to write that as P. Remember, for perimeter, what we do is add all the sides up. So that would be 4 plus 4 plus 4 plus 4, right? Also 4 times 4. We'd end up with a perimeter of 16 inches, right? Now, another way of saying what perimeter is it's the distance all the way around the square, right? So we are going to be talking about how to do that now with circles. We haven't learned yet how to figure out the perimeter of a circle because there's no sides for us to add up. Okay, so here is a little bit of vocab that you're going to want to write down. First thing is, what is a circle? We've seen them. We know it's kind of a simple thing. What's a circle? But the actual definition, right, is when you have all the points on a plane, because remember, imagine that you're plotting these points and they're the same distance from the center, meaning no matter where on that circle that I pick, whether I pick a spot here or whether I pick a spot on the other end, it's all going to be the same distance from the center. Now, we have two important terms. One is the radius. That's the distance that is halfway across the center. And the diameter, which is the distance all the way across the center. So the diameter is twice the radius. The radius is half the diameter. So we are going to be starting by doing some problems where you have one and you need to figure out the other. So if I have the diameter, what's the radius? If I have the radius, what's the diameter? So first thing, write this down, draw that illustration so that you can know exactly what a radius and a diameter represent. So here are our equations. For diameter, it's D for diameter, equals 2 times the radius. And that makes sense because it's twice as large as the radius, right? The radius is only halfway across. And to figure out the radius, which is R, you divide the diameter by 2 because it's half the diameter, right? So that makes sense. So now we're going to do a couple problems. And if you're following along with me in the book, I'm going over example 1. So the first one says you have a circle where the diameter is 20 feet. So that means I have a D of 20 feet. And I want to know, what is my radius? So if I were to use my formula, I'm looking for radius. So R equals D over 2, which is the same as 20 over 2 for this problem, which means my radius is 10 feet, right? And you could also think about it if just split the diameter in half. What's half of 20? You already know that. It's 10. Okay, there you go. Let's do another one. The next one says, what if you have the radius that is 7 meters? So if I have a radius that is 7 meters, right? And I'm looking for the diameter, then I know that D equals 2R, or here, 2 times 7, which we know is 14. So our diameter is 14 meters. That's simple. So I want you to pause here and try and do numbers 1 and 2 right there on that paper. If you don't have your book with you, I'll tell you, this is the problem for number 1. It is you have a diameter of 16 centimeters. What's the radius? And then for 2, it's a radius of 9 yards. And what is the diameter? So pause, take a second to solve those, and then I'll have the answer here. Okay, so for the answers for these, number 1, you should have, you're looking for your radius. So radius equals 16 over 2. So we would have 8 centimeters for number 1. And for 2, we're looking for diameter, which is 2 times the radius. In this case, that is 2 times 9, which would have given us 18 yards. All right, so moving on to the next example. Okay, so at the beginning of this, I told you we would start by finding out the perimeter of a circle. Well, actually, when we have a circle, we don't use the term perimeter. We use a different term called circumference, but it means the same thing. Basically, a circumference is the distance all the way around the circle. So you will see here that it's a capital C that represents circumference. That's the distance all the way around, just like perimeter is the distance all the way around. All right? But again, you can't just add up your sides. So this is where that diameter and that radius you just learned about is going to come into play. So how we calculate the circumference? We can use one or two equations. First one, we can either do your circumference equals pi times the diameter. Remember, the diameter is the area all the way across, that distance all the way across the circle. Or you can use the circumference equals 2 times pi times r. And that is because if you multiply the radius, which is half the diameter, by 2, then that's the same thing as the diameter, right? So those are pretty much the same thing. The new thing here is this pi. Pi, spelled like this, not like the edible kind that I love, is basically a Greek letter, and it represents a non-repeating decimal. For the sake of this, we are going to just note pi to be 3.4. Now, your book also says that sometimes it's easier to use 22 over 7 if it's a multiple of 7. And while that's true, when you're rounding, you're going to get the same answer. So I think for right now, it's just simplest to use it as 3.14. Now, on most of your calculators, especially if you have the kind that we have at school that we usually use, there is a button for pi, and it will look just like this symbol, and you may use that button as well. If you use that button, your rounding may be a little bit off just because on the calculator, it's not going to just use 3.14, it's going to keep going. So that's fine. You can either type in 3.14, or if you have the calculator, you can just use the pi button. You will still get the right answer. You'll just have a rounding that's a little bit different. Maybe your decimal will be a little bit off. All right, so let's try to use this equation now. Let's say that I wanted to find the circumference, so basically the distance all the way around a Frisbee. And let's say that we knew the radius of the Frisbee was 5 inches. That's the only information that I have. Now, if I wanted to use the first formula, which is C equals pi times the diameter, I could just know in my head, well, if the radius is 5, then that means the diameter is 10. So that would just be 3.14 times 10, right? Or if I wanted to use the second one, which we'd probably do because we're looking at radius, 2 times pi times r, then we have 2 times 3 3.14 times 5. Both would have given you the right answer, though, which will be somewhere around 31. Okay, there you go. Oh, and by the way, this is inches. That's the first example for you. We'll do another one. Okay, so our next example of circumference, if you look at your book, we're still on page 363, says that you have a circle on a watch band. This time you have your diameter instead of your radius, and it is a diameter of 28 millimeters. All right, and they're asking for the circumference again. So since we have diameter, I think the easiest formula here would be pi times the diameter, right? Otherwise, you would be dividing to find the radius just to go back to the diameter. So here we have pi times the diameter, and we know we're just using 3.14 as pi times our diameter, which is 28. And that would give us about 88 as an answer. Millimeters. There we go. That's your circumference. All right, so now you're going to pause again and you're going to try to solve these before I do it. So these are the 3 problems on page 363. First, you have a circle with a radius of 2 centimeters, one with a diameter of 14 feet, and one with a diameter of 9 inches. And you're going to try to find the circumference of all of these. So pause, try to do those, and then check your answers back with me. All right, so your answers for 3, you should have had about 13 centimeters, about 44 feet, and about 28 inches. And I just rounded all those to the nearest whole number. All right, so now last section. Okay, so now the last part of this lesson. So what happens if I actually want to find the distance all the way around half of the circle, right? I can't just use circumference because this is not a full circle, right? And I can't just divide the circumference by 2 because there's also the straight line part. So what we'll actually do when you want to find the distance all the way around a half circle, we're going to call it perimeter again because now we have a side, but it all means the same thing. Perimeter is just the distance all the way around a shape. So whether it's a square, rectangle, triangle, semicircle, circumference is the distance all the way around a circle. So think of it as like a special type of perimeter. So if we want to find the perimeter of a semicircle, it's half of a circle. So we'll find the perimeter of that circle, which is the circumference, and then we'll divide that by 2 and add that to the side length. So if we were to write that out, it would look like this. So if I want to know perimeter of a semicircle, I'll take the circumference, right? Divided by 2. There we go. Plus the diameter. And that will equal my perimeter of a semicircle. And that makes sense because we have half the circumference and we add that to that straight line part, which also equals the diameter. So now let's try that. First, let's figure out for this semicircle right here, what is the perimeter? First, let's figure out what would be the circumference of that circle. And we have the diameter. So remember, circumference equals pi times this diameter, which is here 3.14 times 6. So that would give us about 18.84. But now we're going back up to this perimeter equation. So we're going to take that and we are going to divided by 2. And after we do that, so make sure you do this first, we are going to add that to our diameter, which was 6. And that'll give us our answer. So we divide this, we should get about 9.42. Add that to 6, we'll end up with 15.42 meters. And if you round to the nearest whole number, it'll just be 15. So we're going to do a couple more of these. Okay, so last 3 examples. I'm on page 364 now. I'll do the first one with you, and then I want you guys to pause and try the second 2. Then you can check your answers with me. So first, we want to figure out the perimeter of all these semicircles. For number 6, we have a diameter of 2 feet. Remember, the diameter is the distance all the way across the circle. So if I want to figure out my perimeter, remember, I'm going to take the circumference and I'm going to divide that by 2. And I'm going to add that to the diameter to get the perimeter. So for the first circle, well, semicircle, we need to figure out the circumference of what that circle would have been. So circumference, remember, pi times diameter, because we have diameter now. So that's 3.14 times our 2 feet, which would give us 6.28. Then we're going to go ahead and divide that by 2, because that's our circumference, divided by 2, and we'll add that number to our diameter. All right, and you should walk away with an answer of about 1.14 feet. So now I want you guys to go and try number 7 and 8, and then come back and check your answer. One thing though, when you're doing number 8, remember this is your radius, not your diameter. So when you're finding the circumference, you're going to need to use that equation that has the radius, not the one for the diameter. All right? All right, so your answers should have been about 18 centimeters for 7 and 77 inches for 8. There you go. And that is lesson 9.1.